Okay, so let's suppose for a second you have a jar. Oops. Jar. Jar? In your jar you have 7 white marbles and 4 blue ones. Cool?
Yeah.
It's more of a bag.
It's like a sack of marbles.
Okay, I'm willing to go with the idea that it's a sack of marbles.
Yeah, there you go.
There you go.
Yeah,
Sack of marbles. Who keeps marbles in a jar anyway?
Nobody.
Unless it's
Maybe
Crazy
put
people.
some flowers in there, some people do that.
Okay, so what I want is to draw 2 with replacement. What the heck does that mean?
You're replacing 2?
That means you're going to draw 1, look at it, and then put it back in the bag and draw the next one. You guys with that? Okay, so let's calculate some probabilities. So let's start with both white. Alright, so here's the question.
Wait, Joe, which ones are white?
Those ones.
Top ones?
Oh, the white one's
Damn it.
That's cool.
Alright, so what's the probability that both marbles I draw are white? First question, what's the probability that the first marble you draw is white?
How many? There are 3, 6, 7, 4, 4, 7. 4 sevens. 7 fourths. 7 factorial over 4. No. Oh.
Okay.
4 factorial over 7 minus 4 factorial, 4 factorial.
Okay, dude, easier.
Okay.
You're not permuting things, right? There's one slot in your
4
hand.
divided by 7. 7 divided by 4. There's
Okay, it's 7 divided by...
4.
How many marbles are there?
Total.
10.
11.
11.
7, 11.
So this is the probability that the first one's white, right?
Yep.
You guys see that? And then, what's the probability that the second one's white?
Not the same as that. 6
6
out of 11?
Remember, you're drawing with replacement, right? So you took it out, you look at it, and you put it back, and then you draw another one.
Just 7, 11 again.
Yeah, so it's 7/11ths again. You guys all with me on that? So that's first one's white, second one's white. Good?
Makes sense.
Okay, so you get 4,921st. Okay, next question.
That's it, huh?
White, then blue.
Six or 7 out of 11, and then times 4.
Wait. How many were white?
7.
7.
7 out of 11.
Okay, so that's 7 out of 11 times 4 out of 11?
Yeah. You get 28 over 121.
Perfect. 28 over 121. You all good with this?
I
This feels like-
harder than this. This seems really easy.
Yeah, this seems pretty easy because it is pretty easy.
Okay, can we do one that we see like on the.
Okay, let's do slightly more complicated.
Okay.
1 white and 1 blue.
That's literally the same one. That's the same thing. It's the one above.
No, it's not. Let me see if I can convince you.
Like
So-
a specific one specific marble? One specific white marble out of the 7?
No. Just say, in your 2 draws, you get a white one and a blue one, or a blue and then a white. You guys see those are different here? So this was white, then blue, right?
Yep.
So I did 7/11 times 4/11. This is either white then blue or blue then white.
So is it like greater chances?
So let me draw a picture. So if I start here with nothing drawn, right? In order to get to white, what's the probability of drawing a white one first?
7 out of 11.
7 out of 11.
28 out of 11? Is that what it is?
To get to a blue one,
4 out of 11.
it's 4 out of 11. If you drew a white one,
And now you're
this would be white, white, right?
Okay. So 7 out of 11 white.
So that'd be 7 out of 11 along this edge. This edge would be white, then blue, right?
4 out of 11.
Which would be 4 out of 11. This would be blue, then
White.
4 out of
White?
11. Oh, wait. Oh. 7 out of 11?
which was 7 out of 11 along this edge, and blue, blue along this one, is 4 out of 11. So if you want to calculate the probabilities of any event in here, really, you can look at, to get to white, white, I have to go along a 7/11 edge and then a 7/11 edge. So this guy here has a probability that is 49 per 121.
Okay.
You guys see that? That's my both white.
Okay. Oh, wait. Do you just do those two and then add them up?
Yeah, so both blue, right?
So 56.
Hang on. So both blue was what? Probability of both blue is, how do you get to blue by itself?
4 out of 11, 4 out of 11.
Yeah, it's along a 4/11 edge,
16 out of
and then to get to blue, blue, you need to go again along a 4/11.
16 over 121.
So this would be 16 per 121. To get to white, blue, you have a probability of,
Can you say it? 28?
yeah, it was 28, we did it over there, right?
Yeah.
And in the tree picture, that's a 7/11 edge and then a 4/11 edge. So that's a 28 per 121.
Yeah.
Is with me? Okay. And the probability of blue, white is again 28 per 121.
So 56 out of 121.
And then these two outcomes together are the one white, one blue. You guys see that? So why am I getting away adding?
Because you got a greater chance of picking them since you're on a specific order.
Yeah.
I'm gonna have the same denominator.
Yeah. So that's why I'm getting away fraction wise. That wasn't quite the question I was asking. So the question I was asking is, why is it okay to do that in probability land? And the answer is, those are mutually exclusive events, right? If you do white first, then blue, that's totally disjoint from blue first, then white. You guys remember that rule about if I have disjoint events, I can add the probabilities? No? Okay, trust me. So, once you get to the end of the branches, if you want to add up a few ends of branches, you can add the probabilities there. You guys good with this? So,
I'm doing examples. Another one.
yeah, I'm going to do another example with out replacement. If April.
Yeah, how do we get to
Yeah,
that
no, I was
answer
just
without
thinking of
drawing-
how to get to it without doing the tree.
So without doing the tree, you could say, alright, so one white, one blue, right? That's really 7/11 and 4/11. I need to multiply those, and then I need to account for the fact that I could have gotten them in the other order.
Okay,
So you can take your 28 per 111 and double it.
gotcha. Thank you.
You guys all see that? That gets a little more complicated when there's lots of arrangements, right? Like if you were drawing 3 marbles, and you wanted 2 blues and a white, then things get a little more complicated and you maybe are best to draw out the tree. I really like the trees, they make me get things right all the time, instead of being right like 80% of the time.